Mark.
Nice to see you again, Maria. All too long. Maria and Sophie were wonderful, are great friends of Becca's and mine, and I miss our regular meetings we used to have back in Sydney, Maria. Tyranny of distance is one of the problems. But Professor Maria Kavallaris, AM, is a leading childhood cancer researcher and a pioneer in nanomedicine. She's a member of the Order of Australia, or she was made a member of the Order of Australia in 2019, and in 2020, last year, was designated as the Premier's New South Wales Woman of the Year for her contribution to cancer research. So Maria, ever since I've known her, has been an avid researcher in that important field. She works at the Sydney Children's Hospital associated with the University of New South Wales in Randwick. It's just been wonderful to follow her career and know, Maria, that you've made such a huge success with your research. I look forward to, as do the other club members, in hearing about where you're heading with it all and where we've got with this important disease that affects all of us in one form or another. So I might, without any further ado, Maria, welcome you to Coffs Harbour this morning in a virtual connection, and look forward to your presentation. I'll leave it over to you.
Right. All right. Well, thank you very much, Mark, and thank you everyone for coming along this morning. It would have been nice to be there in person, but travel's not so easy anymore. Look, I just thought I might give you a little bit of a view of my journey, and then talk a bit about some of the work I do now. I guess I was reflecting that it's actually hard to believe that 25 years ago I was actually graduating with my PhD at the University of New South Wales. And I guess at the time I could not have predicted, I guess, what choices I was going to make, what doors would open, nor the opportunities I would pick in the twists and turns of journey called life. So I'm one of 5 children and a first-generation Australian. My parents are from Cyprus, a little island in the Mediterranean Sea. Having immigrated to Australia as teenagers looking for new opportunities, my parents met and married here and created a new life for themselves. My father worked on the Snowy Mountains scheme, and my mother worked as a seamstress in a leather factory in Sydney. My father often had to work 7 days a week to support us, although I really do think my mother had the tougher job of bringing 5 kids up under the age of 10. When I was 9 years old, my parents moved the family to Cyprus. We lived there for 3.5 years before war broke out. It was a pretty scary time, and the town we lived in was occupied by invading forces, and my parents lost everything they owned. Given the circumstances, we returned to Australia, where my parents started back from scratch and rebuilt their lives and looked after us kids. I believe their resilience has been my inspiration. I reflect on the fact that neither of my parents were given the opportunity to go to high school and complete their education when they were growing up. Yet they valued the importance of education and a better life for their children. Their determination and hard work to build a better life and provide opportunity to children moulded my work ethic and determination. I always loved science, and at the age of 15, I left school after year 10 to train as a pathology technician. Now, as you can imagine, without experience and being young, I struggled to get a pathology job. In life, where one door closes, another one opens. So I actually landed my first job in a research laboratory at the University of Sydney, working in brain research. This actually opened up my eyes to a world of opportunities in medical research. As soon as I completed my TAFE course, I enrolled in university to start my undergraduate science degree. I did this part-time as I needed to support myself. After 3 years at the University of Sydney, the research funding ran out. It's a common problem in research. I found a new position that little did I know would change the course of my career. I landed a job as a lab technician in cancer research at the University of New South Wales. As much as we plan and organise things in our life, we often have to adapt to changes, the road signs of life. At the age of 21, I was diagnosed with cancer. This I classified as a sharp left turn in life. After surgery, I started high-dose chemotherapy. The treatment was aggressive due to my age, and the side effects not only unpleasant, but at times life-threatening. Halfway through my treatment, the head of my laboratory was offered the position to head the then new Children's Cancer Institute, a medical research institute dedicated to finding the causes and treatments for childhood cancer. In my new role at the institute, I met children diagnosed with cancer and saw the impact of their treatment and how the loss of lives affected their families. I was determined to do something about this and make a difference to the lives of these children and their families affected by cancer. So I made a commitment to myself that I would train and become an independent scientist. So as soon as I completed my undergraduate degree, I enrolled in a PhD program at the University of New South Wales and the Children's Cancer Institute. In the first year of my PhD, there was another unexpected fork in the road of life. My 30-year-old brother, who was a primary school teacher, had an aggressive cancer and died 3 weeks after being diagnosed with the disease. This really cemented for me that there was people who could get treatments and people who had no options of treatments. These life experiences cemented my resolve to dedicate my life to cancer research. After finishing my PhD, I was fortunate to be awarded a prestigious World Health Organization fellowship to train at the Albert Einstein College of Medicine in New York. Living and working in New York was an amazing and enriching experience. Despite being offered an excellent research position in the USA, Australia was home, and I wanted to bring back the knowledge I gained. Returning to Children's Cancer Institute and the University of New South Wales, research to understand how cancer grows and spreads and what causes it to become resistant to therapy. Something a lot of people are not aware of is that cancer still takes the lives of more children than any other disease in Australia. Today, in any major children's ward cancer ward in Australia, 50% of the children are being toxic side effects of the very treatments that are being given to cure them. This is very sobering. My own experience with cancer therapy and meeting so many children who were impacted by the treatment made me realise that firstly, this is not good enough. Secondly, we can do better. And thirdly, that through research, we will do better. To tackle a challenging disease like cancer, a multi-pronged approach is needed, and one that needs multiple great minds. I established an interdisciplinary team that includes biologists, chemists, engineers, and doctors to develop new technology to deliver therapy directly to tumour cells so that healthy cells are spared. And I did this through establishing the Australian Centre for Nanomedicine at the University of New South Wales, one of the two hats I wear along with the Children's Cancer Institute. My hope is that one day we can cure more children and adults with cancer and limit the harms of the therapy. The challenge is that we all have a unique genetic makeup. Equally, every cancer has its own genetic and biological signature. This is why some children's cancers do not respond to standard cancer treatments, because every child and every cancer is different. Knowing this, at the Children's Cancer Institute, we embarked on the world-leading program, Zero Childhood Cancer. This is the largest single initiative ever taken for children with cancer in Australia, and we do this in partnership with the Sydney Children's Hospital. The program means that children with the most aggressive cancer have their tumour samples sent to our labs. Then, leveraging the most innovative research, technology and tests, we precisely analyse the genetic makeup of each individual child's cancer. We can then identify the drugs that have the greatest likelihood of being effective against each child's cancer, and through this personalised treatment, give each child the best chance of survival. The ultimate aim of this program is to deliver the right treatment to the right child at the right time. I want to share a story about a young girl called Ellie. I know her family quite well. In August 2017, Ellie's parents brought her to Sydney Children's Hospital at just 11 months old with a sarcoma tumour so large it had forced her heart from the left to the right side of her chest. She was treated with high-dose chemotherapy and the tumour continued to grow. Basically, the parents were told to start making arrangements, end-of-life arrangements. When Ellie's tumour samples were sent to our team, we were able to identify a specific genetic change we believed was driving her cancer and match this to a drug to target that change. Now, this drug had just been made in America, so it took a lot of hurdles to negotiate and get this drug given to us from the unit grounds because it was not approved for treatment at that point. Within a few weeks of receiving the treatment, Ellie's tumour began to shrink. Today, Ellie is alive and well because of our Zero Childhood Cancer program. She just turned 4. There are other amazing stories like Ellie's. While we cannot find treatments for all children with cancer and more research needs to be done, we will continue towards 0 deaths from this disease. One of my favourite quotes from Albert Einstein is that imagination is more important than knowledge. I believe that if we can imagine, we can create. And that's what we're doing at the Children's Cancer Institute. We believe we just need to think outside the box and really come up with creative solutions so that one day we will cure children with cancer. And it's not if, it's when. Thank you.
Thank you, Maria. That was a wonderful snapshot of all your work and the goals. Can you explain to me what nanomedicine is? Is that a term that's been around for some time, or I know you're a pioneer in that area, but is that something that you initiated, or that can you tell us a bit about nanomedicine?
So nanotechnology has been around for some time. Actually, probably a lot of you are not aware, but you have nanotechnology all around your life. You know, the paints on your car have got nanoparticles in them. Some of those socks that don't fall down when you wear them have got nanoparticles in them. The paint on our houses have got nanoparticles in them. So this is nanotechnology. So nanomedicine is the application of nanotechnology, which is the engineered materials at the nanometer scale. And to put that in perspective, that's 1,000th the width of a human hair. So nanotechnology has been around, and people have been trying for probably 20 years to try and apply it to medical applications. And there's actually been some successes. So many of you may or may not be aware that a number of the new vaccines for COVID are actually in a nano formulation. So they're in what we call liposomal formulations, which was all developed from nanotechnology. So what is newer, Mark, is that there wasn't as many people in Australia dedicated to doing cancer nanomedicine. So, you know, we established the Australian Centre for Nanomedicine with the idea of actually bringing together diverse disciplines, because the problem I found when I first got involved in this field is that a lot of chemists and material scientists were working on nanomedicine, but really didn't have the expertise to translate it any further than what they were publishing these good papers but not really, moving it forward to application. So we felt that if we could actually bring all these disciplines together, that we would have a better chance of actually translating our discoveries and also using the expertise, because science has become so big that it's really hard to retain all the information from everything. It's even just keeping up with my own field is enormous, let alone keeping up completely with the material science field or the physics field or the chemistry field. So yeah, bringing these minds together really has been a big coup, and the centre has been highly successful. So probably cancer nanomedicine is something I'm better known for in Australia, specifically in that field. Another thing I should point out that there are a few nanomedicines for cancer, not many of them, and many of them are a bit like the vaccine. They're what we call, they're systemically delivered. So that means you just, you give them intravenously or you give them intramuscularly, depending on what you're treating. And that's okay. But when you're talking about cancer treatment, one of the things you want to do is, like a lot of drugs, even standard drugs, they get excreted out of the body rapidly. And what we want them to do is get trapped at the tumor sites. So we're now modifying these, we're working on modifying these nanoparticles. So they're not, we can actually attach little, what we call antibodies on the surface of these nanoparticles, and they recognize what we call the antigens. It's like a lock and key approach on the surface of cancer cells. When that happens, they can then get dragged and release their cargo. And in our case, it could be a chemotherapeutic drug. It could be a piece of genetic sequence to switch off a cancer gene. And we're working on those type of approaches at the moment. So that's pretty exciting. So I can't claim to have invented nanomedicine, Mark, but we've made big strides here in Australia in cancer nanomedicine.
Thank you, Marie. I'll just mute the microphone because it's been bouncing back a bit. Does anyone have any other questions for Professor Kavallaris?
Yeah. Thank you.
Everyone's in awe of the work you're doing, Maria, and so keep it up.
Thank you. Look, I'll just say something. It's a question I often get asked, and probably someone will think about it afterwards when I get off the Zoom call. People often ask me, why do we do research in cancer? Why can't, can we just use stuff from adult cancers? And the reason is that the genetic changes that occur for a childhood cancer to occur are very different to what happens in an adult cancer. So for example, adult cancers, because we've been around for a long time, acquire multiple genetic changes. While interesting in children's cancer, genetic changes like mutations are relatively rare. What you tend to get is rearrangements of the genetic material rather than mutations per se. So the biology is very different. The drugs are always tested on adults and then they're tested on children, but they're not designed for children, hence the very toxic side effects of the treatment. So one of the challenges is that we've got, that one of the wonderful things, it's a challenge and a great thing as well, is that we have more cancer survivors, childhood cancer survivors now. So in Australia, 1 in every 900 adults is a survivor of childhood cancer. And that, which is an amazing feat, given it is the most common, form of disease-related death in children. But the problem is that close to 70% of those adults will have some long-term effect from their treatment. Some will be, about 30% will be quite severe, but, up to 70% will have some long-term issues. So it's not just about curing, which we want to do and we want more kids to survive, but it's also about doing it without causing harm. Hence my passion about nanomedicine, because we might release therapeutic in the cells.
Thank you so much, Maria. On behalf of the Rotary Club of Costa Rica, I do express our sincere gratitude for you taking time out to join us so early in the morning. Don't know about you, but it takes me a bit of effort to get going this early in the morning. But,
well, I haven't had my first cup of coffee yet, Mark, so I did pretty well. So.
Well, you go and enjoy your coffee because I know you've probably got a big day ahead here. Pass on my love and regard to Sophie, and we'll talk down the track. Will everyone
Great.
please?
Well, thank you so much. Thank you, everyone. And thank you for the invitation. See you later.
Maria,
Bye.
just connect.
Wow.
Oh, thanks. Yeah, so that was it.